These are the notes for NTI12, special right triangles. So in geometry, you all learned that there were two right triangles that were considered special. They have their own little list of formulas. So the first one we're going to look at is for the 45, 45, 90 triangle. So basically, when you have a right triangle and the two acute angles are congruent, you know those two angles have to be 45 degrees each. Okay. So when that scenario happens, the formulas for your sides of your triangle are x and x for the legs, because if you remember, when you have congruent angles, the sides across from those also have to be congruent. And then that's going to make the hypotenuse x radical 2. Okay. So let's look at a couple of examples on how to use that to be able to solve for the missing sides on a right triangle. So first example, we have a triangle drawn, and this is our right angle up here. This is triangle ABC. So C is the right angle. Angle A is 45 degrees, and so is angle B. And you know that these two sides are 2 meters. And this one asks you to find side AB. Okay, so we're going to compare this triangle with the triangle that I have my formulas written out for. And if you will notice, the two legs, the ones across from the 45-degree angles, the ones that meet to make the right angle, those are both x. So this would be side x, this would be side x. Side AB is my hypotenuse, so it's x radical 2. Okay. So I take one of these sides that I know and set it equal to the formula that I have for that side. So this tells me that x is equal to 2. So if x is equal to 2 and I want to find side AB, my formula for side AB is x radical 2. We just found that x is 2, so that side's going to be 2 radical 2. Okay, next example. This time, our right triangle. Once again, we've got ABC with C being the right angle. There are my 45-degree angles. And this time we know side AB is 5 centimeters. And we want to find AC. And we want to find BC. So we compare this with our formula triangle. These are our legs, so those are x. 5 is the hypotenuse, so it's x radical 2. So this is the side that we know and the formula for that side. So we write x radical 2 is equal to 5. And we can't leave... now we have to solve for x. So how do we get rid of that radical 2? Well, the radical 2 is multiplied by the x, so I'm just going to divide. And that gives me x equals 5 over radical 2. Now, if you remember from algebra, we don't like to leave a radical in the bottom. So if you're asked to leave your answer in radical form, then you need to simplify this by multiplying the bottom and the top by radical 2. That's going to give me 5 radical 2 on the top over the square root of 4 on the bottom. And what's the square root of 4? So we change that radical 4 to a 2. Now, if you are asked to just write it in decimal form and round to a certain amount, then you should be able to just take this value right here and put it in your calculator. When you put that in your calculator, you end up with about 3.536. Okay, and then remember our units are centimeters. Okay. So just pay attention to your directions on MATLAB as far as does it want the radical form, then you would need to have 5 radical 2 over 2. If it just wants the decimal form, then you don't have to do all the rationalizing that we did, and you can just type in your fraction in your calculator and then round to however many places MATLAB is telling you to round. Okay, and I think I forgot to put my units on that first one, didn't I? What were those? Meters? So that should be 2 radical 2 meters there. Okay, so those are the 45, 45, 90 triangles. The other type of special triangle is a 30, 60. So that's what we're going to look at next. Okay, so on the 30, 60, 90 triangle, the shortest side has to be across from the smallest angle. So my side across from 30 is going to have the formula of x. Okay, the other leg that's across from 60 degrees is going to be x radical 3. And then the hypotenuse is 2x. The hypotenuse has to be the longest side of your triangle. And if you're getting the formulas confused, multiplying by 2 would make a bigger number than multiplying by radical 3. Okay, that's just because 2 is the same thing as radical 4. So radical 4 is a bigger number than radical 3. All right, let's look at an example on how to work through a problem like this. Okay, this time, this is our right triangle with my 30 and 60 degree angles. Angle C, once again, is my right angle. We know this side is 7 inches. That side AC. We want to find AB, and we need to find BC. Okay, so compare the triangle in our example with the triangle that we have the formulas for. Okay, that one's not rotated differently or anything. Okay, so we should just be able to set it up pretty easily. The side across from 30 is x. The side across from 60 is x radical 3. And the hypotenuse is 2x. Okay, here's the side we know and the side that we have a formula for. So that tells me that x is equal to 7. If x is equal to 7, then I can come here and replace that x with 7. So that makes BC 7 radical 3. And then I can come over to my hypotenuse and replace that x with 7. And so that makes AB 2 times 7, which would be 14. And these are both inches. Okay, another example like that. Okay, this time we're given, let's see, A, B, C again. Okay. And we're given that AC is 8 centimeters. And we need to find AB, and we need to find BC. Okay, this one's turned a little different, so make sure you're careful when you mark your formulas onto the triangle. But the shortest side is the side across from 30, so that's the one that has the formula of x. Okay. The other leg is x radical 3, and then the hypotenuse is 2x. So here's where I come up with my equation. X radical 3 is equal to 8. Okay, so to get x by itself, I divide by radical 3. So x is equal to 8 over radical 3. Now, once again, if it tells us to write our answer as a radical, we can't have a radical on the bottom. So I'm going to multiply that by itself so that I end up with 8 radical 3 over radical 9, and the square root of 9 is 3. So that's my answer for x, which is side BC. So I'm going to put 8 radical 3 over 3 here, and this is centimeters. Okay. If it just asks you to do the decimal value, then you can type in 8 divided by radical 3 on your calculator. You don't have to go through all these other steps, and that's going to be about 4.6. So I could say 4.6 centimeters. So once again, just watch what MATLAB is asking for. If it asks for radicals, leave your answer as a radical. And then if it allows decimals, then just make sure you're rounding to whatever it's asking for. Okay, then the last thing I have to do is to find the hypotenuse, which is AB. The hypotenuse, I just need to multiply by 2. So if I need the radical answer, then that just means I'm going to take, for AB, I'm going to take 2 times 8 radical 3 over 3. That would give me 16 radical 3 over 3. Because I just multiplied 2 times 8, because this is like 2 over 1. Okay, if it only wants the decimal form, then I can take my 4.6 and multiply that by 2. And that's going to give me 9.2. And you should have the same answer whether you type in 6 radical 3 over 3, or if you just take your 4.6 times 2, either way. Okay. So that's the end of today's lesson. That should help you out with your special right triangles. This was NTI 12. You're a